In this demonstration, you'll learn about the workflow for simulations in AIM. We're going to walk through a structural simulation to simulate the effects of a pressure on the inside of a steel pipe. To get started, we'll choose a template that matches the physics we'll be solving. Here's the structural template. Many of these templates have multi-physics options. We're working with structural only. Let's leave the rest of the defaults as they are. When you click Create Simulation Process, you'll be prompted to import the geometry file. The model is shown in the graphics viewer. The template creates the tasks for your simulation. You can see them here in the Workflow tab. Each of these tasks is a step in the simulation process. When you click on the task, you'll go to the Tasks Data panel. Each of these tasks acts as a container for all of the objects and settings within that step. You can see that the Physics Data panel lists the objects it contains, such as the material assignments and boundary conditions. Let's start working through the tasks. The mesh task is the first one that needs to be updated in this simulation process. I'll click on it to open the data panel. Yellow means this task is ready to be updated, but first let's review the setup. We need to decide how fine we want the mesh to be. Especially for large models, it's good to start with a lower mesh resolution so that your first solution is calculated quickly. So let's keep this default. You can always come back and refine the entire mesh, or add controls to refine the mesh in areas of interest. The task can be updated here in the Tasks Data panel, or down here in the Workflow tab. Updating the mesh task generates a mesh. The physics task is next in the workflow. Here, you set up and solve the physics solution. Let's go to the Physics Tasks Data panel. The template added objects to the tasks, as well as other default settings. If needed, all of these objects and settings can be changed to match your specific simulation. In the physics task, the physics region defines what type of physics you are solving. The template has set the physics region to structural. The location field shows that all three bodies in the model are part of this physics region. There are cues to help you set up this physics task. Attention required means that objects are missing or need to be fixed before you can update this task. If you look in the Messages tab, you'll see a summary of the changes needed. Here's a cue to add boundary conditions. You can add objects here in the Tasks Data panel. We'll add a pressure boundary condition. Here, we need to define the location on the model where we want to apply pressure. Pressure can only be applied to faces, so we'll make sure we're using the face selection filter. Select the locations and use the Add button to add it to the location field. If you want to change the selected locations, use the Replace button. We want to apply the pressure to the inside of the pipe. Use the Control key to select multiple locations at once. The location is listed when you click inside the field. Another way to add boundary conditions is to select a location on the model and right-click. The options that appear here depend on the task that you're in. In this physics task, these options are also specific to the type of physics region, in this case, to the structural physics region. This task is now ready to be updated. Before we update it, let's just make sure the material is structural steel. Updating the physics task solves the physics. Information about this solution process is available in the Transcript tab. Once the physics task is up to date, the Results task lets you visualize the solved simulation results. The template has already added 2 results. They need to be updated before you can visualize them. You can add more contours, vectors, calculated values, or isosurfaces to review the variables of interest for your simulation. Update the results individually, or update the results task to evaluate all of the results at once. After you review these simulation results, you can assess if you need to do another simulation with any refinements or modifications to the model or the physics setup. Let's review the tasks in the Workflow tab and what we did in each of these steps. The geometry task imports the model. The mesh task generates a discretized mesh. The physics task solves the physics, and the results task evaluates the results. This concludes the demonstration of the workflow in AIM.